Hi, I'm Jose Fernandez again, and here I'm going to do another related rate problem. In this one, the problem is a plane flies at an altitude of 5 miles toward a point directly over an observer. The airplane's speed is 400 miles per hour. Find the rate at which the angle of elevation is changing when the angle is pi over 4. So you can see that I already did a diagram here. Let's put altitude as y, and it's equal to 5 miles per hour. Then the angle, for now we're going to leave it as theta. And then the horizontal distance, we're going to put it as x. So now at this moment we're writing the given, and we put theta is equal to pi over 4. Then the dx over dt, or the rate at which the x is changing, in this case is the plane's speed, so it's 400 miles per hour. However, notice that it's flying toward you, so this is actually decreasing. So let's go, it's decreasing at a rate of 400 miles per hour, so we're going to put it as negative. And then y, or the altitude, is going to be 5 miles. Okay, so now since this is a different kind of problem, so since we're dealing with an angle, we have to find the relationship between that angle and two angles. So we have both of these sides, so this looks like a tangent situation. So we write the tan of theta is equal to 5 over x. And now we take the derivative of that, which ends up being secant squared theta d theta over dt is equal to negative 5 x to the over x squared, because 5 over x is the same thing as 5x to the power of negative 1. So we take the negative 1 to the 5, which ends up being negative 5. And then x, we subtract 1, it ends up being negative 2. And then times dx dt. Okay, now we can simplify this even further. Secant is the same thing as 1 over cos, so secant squared is the same as 1 over cosecant squared theta d theta dt is equal to negative 5 x squared dx over dt. Now, since we have this simplified, we're trying to... Oh, well, that was odd. I forgot to write what we have to find, which in this case is d theta over dt. But anyway, going back here, we have to isolate d theta over dt, so it ends up being d theta over dt. Then we divide both sides by 1 over cos squared, or in this case, to make it easier, we multiply this side times the reciprocal of 1 over cos squared, which ends up being cos squared. So this ends up being negative 5 cos squared theta divided by x squared times dx dt. Okay, now we have a big problem. We have no idea what x is. However, we can find it by plugging it into this equation. As you can remember, theta is equal to pi over 4, or in simpler terms or numerical terms, it ends up being equal to 45 degrees. And in 45, you guys can remember the special triangle, the 45, 45, 90. And the proportions are 1, 1, and root 2. So we take the tan of 45, or opposite over adjacent, which in this case it's just 1. We take it over here, so 1 is equal to 5 over x. We multiplied both sides by x, and x ends up being equal to 5. So now we have this out of the way. So this can be simplified to d theta over dt negative 5 cos squared theta divided by x squared, x being 5, meaning that this would be divided by 25. And then now that we're in it, we can plug in the value of dx over dt, or the speed, which in this case it's negative 400 miles per hour. Okay, so at this point, we also have to figure out what cos theta is. The cos of 45, or the adjacent over hypotenuse, ends up being 1 over root 2, and that squared ends up being 1/4. So this becomes negative 5. Oh, sorry. It's not 1 over 4, it's 1/2. So negative 5 times 1/2 divided by 25 times negative 400. Okay, so now in even simpler terms, this is 5 over 2 divided by 25 times negative 400. And if we're going to simplify this, it ends up being negative 5 over 2 times the reciprocal of 25, which is 1 over 25, which ends up being negative 5 over 50, or just negative 1 over 10. So let's go over here, negative 1 over 10 times negative 400, which turns into 400, sorry, ignore that. 400 divided by 10. And then 400 divided by 10. Sorry about that. So the answer ends up being d theta over dt is equal to 40 degrees per hour.